you an intro.
Okay.
You deserve it.
You want an embarrassment?
No, I won't. I don't think so. Practice my Toastmasters. I had to do that for some reason, you know.
Yeah.
Hey, ladies and gentlemen. Thank you for coming. I'm asking everybody to move up forward. We owe it to our speakers. He wants to see your faces. He wants to see how you react to his amazing comments and things. And it's just nicer. You've all presented probably, and you know, the closer the better. Right, Jack?
Right.
Exactly.
You will heckle?
Then you get right up front seat then. So this is the last of the PDH course sessions, but it certainly isn't going to be the least one. This one's titled The Design Process from Concept to Commissioning. When we get done, those of you that want your PDH credits, you've probably all heard this, but that table will have the sign-up sheets, and we definitely need your signature on it. Today's speaker is Don Penn. I think this is your first time at a NY-GEO conference, so we're really lucky to have him. He's come all the way from North Texas, so he's traveled a lot and hopefully didn't have too many air traffic problems. I didn't realize this, but Don and I were neighbors. I thought, Garen, we were close, but Don and I were literally in the next communities when I moved there in 1981, and he's from a place called South Lake, which at that time was basically cow fields and the best football team in the state for about 20 years, high school football team. And now you totally wouldn't recognize it. I don't think there's a farm field left in South Lake. So you hit it right probably for the development and the
Right.
geothermal part of it. The other thing that I find amazing about Don, maybe some of you are equal to this, but he has at one time or another been registered as a engineer in 49 states and the District of Columbia, and the only one he misses was Alaska, right?
Yeah.
So definitely a qualified individual, definitely got years and years of experience. It's a pleasure to introduce him, and please give him a round of applause to get him started.
Well, good afternoon, everyone. I'll try to make this quick so we can get to happy hour or whatever it is following here. You know, I just to give you a little background on me, I didn't have the insight to really grasp onto geothermal. I had a client that forced me into it back in 1991. So my first job, my first design that actually got installed was in 92. So that's how long ago I got involved. And he drugged me around the state and showed me different things that were going on in Austin, took me up to Oklahoma, introduced me to a guy named Phil Shane up there, and he kind of schooled me on it. And then I got with Dr. Bose from ICSPA, if you guys know that name. And I just kind of came up with my own deal and my own concept of design. And I'm going to share some of that with you because I think it's important as you're designing your own project. So we'll get into this. That's what you saw. So here's our learning objectives. It's just to common cause of HVAC and geothermal commissioning failure. So now that my company got bought out 2 years ago, I was the sole owner. And during my tenure in that company, I kept getting calls to serve as an expert witness on different aspects of the geothermal systems or geothermal projects. So I got into that. So when I retired, I was thinking, well, I'll toy with that a little bit. Well, it's turned into a job again. So and so now I call myself a litigation consultant. Kind of dress it up instead of saying expert witness. So these are the things we're going to talk about, and a lot of it is from what I've seen in these cases that are going on. I typically keep 12 to 15 cases active, is what it seems to be it's what I'm seeing, and out of that, a third to a half of them are geothermal related. I'm an actually licensed mechanical and electrical engineer, and I've just dropped a lot of states just because I don't, I'm not really practicing anymore, but I kept around Texas and kept Arizona and a few others, but that's what we're going to talk to. So the biggest thing I see is we're talking about why commissioning often fails, and the earlier presentations have really played into this, and those guys have actually talked a lot about it, and it's really interesting to hear them talk because I had not seen their presentation, so I was really encouraged that they're seeing the same thing I am. But you know, the project completion and occupancy occur simultaneously, and I don't know if you guys have seen that. You've got an owner that wants to get in his building, and your commissioning guy, you know, they call the commissioning agent to come out, you know, and we're talking about in the final stages to do start his deficiency list, if you will, and he begins those, and you know, in looking through all the documents on these cases, you see, you know, he's got 200 deficiency items on a list. Okay, you see the list. There's never any follow-up as to whether there was a remedy or not. You know, and you get out there, and sure enough, it hasn't been remedied, and that's what we're dealing with. You know, and you know, you're starting up a facility with the owner on top of you. He's moving in because he's got an opening date or whatever the facility is, or he has to have he has to have that project open or that facility open on a certain day, and there's no moving that. So everybody's at the end of the project, unfortunately, like it is, everybody's on top of each other. Equipment's not even started up, and it should have already been commissioned, and it's not commissioned. And so here we go, and it's really disappointing to see how commissioning's been treated. It's very important, especially with the design concepts that so many engineers are using, and I'm seeing so many engineers that aren't, I use the word qualified. They've never designed a geothermal system, or maybe this is their second or third one, and they get out and they get to doing some, I'll call them unnecessary complications to the systems. And then you've got an owner that doesn't really have a good maintenance staff. And so you're giving an owner a system, and he has no way of maintaining it. And then to further that on, you don't provide a sequence of control, so they don't even know how this thing is supposed to function. They're just, you know, they're trying to operate it, and I'll get into some of that in a few minutes. And like I was saying, you just see, you know, at the end of the day, the number one thing is the owner's not satisfied with it. And then automatically, like we've heard Garen say and everybody else, then geothermal gets blamed for it, like it's the ground. That's the whole problem, you know. And that's not the problem. The problem is an engineer that wasn't competent in what he was doing, and maybe even a contractor, or maybe a combination as you're seeing the project being completed. You know, and the main thing is that commissioning should be completed, you know, prior to substantial completion. And that's gotten flipped. I mean, I see them trying to do commissioning a year after. And on those deficiencies lists, you see major things. I mean, you see valves installed backwards. You know, a perfect example, we had one that had a dry cooler on it, and it was never hooked up. It wasn't running. Another one had a cooling tower on it. It was running, and water was flowing through it, but the pump wasn't running through the basin. So there was it wasn't doing anything, but just out there running. So that's the kind of thing, and this is after 3 or 4 years of operation. That's just the level of competency of what's going on. And the engineers don't insist on being involved in construction administration. And that's, if you're going to do one of these things, in order to be successful, you really got to lock in on having construction administration responsibilities. You really have to do that, because that's what's getting neglected as well, and that's part of the commissioning as well. So you get the TAB, and then with their deficiency list, test, adjust, and balance, and then you get the commissioning agent with theirs. They call one or the other out, and they're not ready, so they get frustrated, and we heard about that this morning. So they'll head to the house, and it's going to be hard to get them back out there because they didn't include that in their price. So here we go. So this just kind of shows a timeline of everything on top of each other. And a lot of these facilities, people don't understand, and I talked to several people, but what happens is, okay, maybe the fix is, when you really break it all down, the fix to the mechanical system or the geothermal system, the cost to get it righted, and maybe have to add some equipment or change some stuff. I mean, it may be $2 or $3 million, but if it's an apartment complex that's full of people, they can't fix it for those people in that building. So now the owner I've got to relocate these people. They're renting from me, so I've got to find a place to put them up for however many months. So all of a sudden this thing turns into $20-25 million really fast. So I don't think people think about that a lot, but it gets pretty crazy. The engineering side of it is a minority of the cost of what you're going to have to be dealing with, and what they're going to be pursuing as far as cost reimbursement from the engineer, the architect, whoever. Most engineering firms carry, what I've seen in some of these areas is only like $2 million. Well, you've got an attorney involved, and you roll into, doing, I've got one of these cases that started in 21, and it's still not resolved. And I was talking to the attorney, and he said, we're already at $500,000 in attorney's fees. So you're sitting there going, so now there's $1.5 million left. And luckily, all I've ever seen them do is just, they want your insurance money at the end of the day. I haven't seen them go after a firm yet, and dive in and have them pony up what that delta was. And so luckily, again, I haven't seen that. And then we talk about, post-occupancy and retro-commissioning. Retro-commissioning, it can provide, maybe a year later or something, it can provide, a check of the health of the facility and give the owner satisfaction. And it's so interesting to see what owners do in the way they look at commissioning, because it is a healthy cost, but it's a healthy exercise too. If you were in some of the earlier presentations, you saw what's involved in commissioning. It's quite a commitment, and that commitment is hours, and that equates into dollars. And so we see owners, everybody's, obviously wants to be efficient with the use of their money, but they don't really understand the implications of not having that commissioning done. So now they come after and get it done, and they see what the health of their building is. And I'm amazed at the attitude of some of the controls contractors in their equipment. And I've asked several of them sometimes when I was doing this, and one of the projects was here in New York, actually, and I'll show you that later, where things weren't fitting around the building. And I said, well, have you calibrated the sensors? And he goes, well, you don't need to calibrate these. They're 20,000 ohm resistor, sensors. You don't need to calibrate. Well, I said, well, let's check a couple. And so we checked a couple, and they're like 3-4 degrees out of whack. And so everybody thinks it's digital. It's 100%. Well, it's not. And then you go into a school environment or whatever, where we've done a lot of research, and those sensors, they don't stay calibrated. And humidity sensors are the worst. And I will tell you right now, giving a owner humidity readings on the thermostat or the sensor is the worst thing you can do. Because those humidity sensors are good for about, I don't know, 12 to 18 months. But that owner goes in there and says, well, this is 68%. I mean, it's too humid in here. You bring in a calibrated device and, you know, it's really 55 or something. Temperature 3 to 5 degrees out of whack is not uncommon. So you can solve a lot of your problems just with calibration, and that would be checked in commissioning too, I hope. And one of the key things in the pre-design aspect, and we'll talk about that in a minute, is get to know your owner and get to know who's going to be maintaining this thing, and then strategize your system design based on what the owner's capabilities are as far as maintenance. Because the worst thing to do is give an owner that has guys that are used to maintaining rooftop units, you know, or split systems. You give him a geothermal system, and the first thing they do is, well, they become very vocal to the owner as once this thing comes online and going, well, I told you this didn't work and all this. So we always try to get with those guys and meet with, we always like to meet with all their staff and as we're going into a new client and get, what their preferences are on all systems. I mean, electrical, plumbing, HVAC equipment, manufacturers they like, they don't like. So you kind of develop a rapport with them and gain their trust, and then tell them about your experience with geothermal. Give them, a tech at another school district or another owner that has had a geothermal system and has had a successful geothermal installation, and let them talk to them so they can get comfortable with it. And then that way you can win them over, because as soon as something happens, they're automatically going to go to the owner. They'll go above their own boss to somebody above and say, hey, we tried to tell him that this is not a good idea. And I've seen that happen several times, when in fact the guy that's doing that doesn't know what he's doing himself. And the classic case I had there was a guy was beating us up, saying there's not enough water flow, it's all this, I told you it wouldn't work. So we get out there, the owner's there. I mean, they brought in everybody. I mean, you've got a meeting of a dozen people to look at some units. Well, you open up a unit, and this was years ago, but, the unit had, the board would tell you how many, if you count clicks or flashing lights on the board, and it would tell you, it diagnose it for you. Well, this guy's been griping to them for 6 months, and we get out there and you count the clicks. Well, the filter's dirty. We pull the filter out right in front of everybody, and it's impacted. And this guy's been, he just didn't want to do his job, I guess, but that's the kind of stuff that goes on. But really, you really need to delve into getting to know your client and understanding, their maintenance capabilities and the temperament of those folks too. And then this is important as well, and we've heard about thermal storage. I did several ice thermal storage systems back in the day, but you really have to understand the usage pattern of that facility. And because with the geothermal, I mean, again, it's much like the thermal storage systems. You have a thermal resource, and it has so much capacity in it, and you're basing that on a use pattern. And if they don't use it that way, then you may experience some issues. And one thing that we have seen, and it's caused problems, is we did a lot of schools. We've done over 350 schools across the U.S. Whenever I was there, and especially in North Texas, the school district would rent out, a gym or a cafeteria or whatever to a church or to a Mother's Day out or to whatever, some type of karate school or, yoga or Pilates or whatever. And and that was happening back then, they would say, once a week maybe, well, it evolved over the years to where they're renting these things out every 7 days a week, every afternoon. Saturday and Sunday, they maybe, have some group come in and be there all day long. So now all of a sudden your load has gone from being 5 days a week, to 7 days a week. So that's a lot different. So you have to be careful when you're designing the bore field. So one of the things I do on the bore field, and when I'm designing the bore field, is I will, in the program, I will, whichever program you like, but I actually run the thing for 24/7 at peak, just to see where that bore field temperature is going to peak, because it will go up and it will turn asymptotic, and that bore field temperature will just will lay out there. And I've seen that, and I've tested it and watched it, and it's pretty accurate. It's not near as accurate what Garen was talking about, but it will give you an indication of what, if this thing, if this owner changes, or if you're doing an office building or something and you've got one owner in there and he has a mode of operation, and that guy ends up moving out or selling the building, and another group comes in, and let's say, they're, instead of running just a 8 to 5 operation, if you will, they're running, two shifts or something. Maybe it's a call center for a credit card company or something that, they have people in there, extended hours. So now all of a sudden you got a building that was designed with a use profile of X, and it's actually being operated as Y now. So that's a game changer as well. And again, working with school districts, you're pretty safe, except for now we know that they use them all the time. And especially high schools in Texas. And I don't know what the use pattern is, maybe in New York so much on the schools, if they actually allow that, or the school districts open them up for that kind of use. But you need to be aware of that. And then as you're doing your specifications, the flushing and purging is extremely important. And then documenting your bore field. We always required a licensed surveyor to locate the top of each bore. And then down your laterals into your building, get those documented so that you know where that bore field is, because that's the number one thing that we see happen. They call me out to look at a system, they're having trouble, and you say, well, where's your as-built? And they go, well, we don't have any. Or they've got some, but it's nothing more than the contractor resubmitted their design documents as the as-built, which it's not accurate. But you can't sort anything out if you don't know where everything is, right? When you get into it, if you really have to get into it, or if you got a leak, you need to know where things are. Or if you're going to add something on the site, you need to know exactly where those bores are. That's incredibly important. And then on your equipment, I've seen this happen where an engineer not familiar with geothermal didn't know what extended range was, or didn't even know what that meant. And so he got equipment that wasn't extended range, but you had a local rep that repped the systems, and then you had a manufacturer that all knew what the project was, and nobody said anything to the engineer. So now we've got equipment that can't function. And the reason it didn't function for them was because the contractor or the engineer, this is in a hot and humid climate, the engineer used a dry cooler. It's a hybrid system, used a dry cooler instead of a cooling tower. And then the owner was operating the dry cooler as a peaking device, so that when his water temperature got above 85 degrees, he turned on the dry cooler. Well, now it's, the temperature's going up outside, so all he was doing was adding heat to his loops. There's not much you can do with that, right? And that goes back to the maintenance capability. So they designed a system for a client that didn't have maintenance staff with the knowledge base to operate that system correctly. And that's one of my things I get on my soapbox about is you gotta know that client, you gotta know their maintenance capabilities, understand how they're gonna be operating that system. And on the flushing and purging, you need to, I think ICSPA says 2 feet a second. Maybe they've adjusted that, I haven't looked recently, but you need to kick it up to at least 6. And you need to design that bore field so it can be flushed and purged. You can't put a bore field out there with 100 bores on it or something and have it all interconnected and flush and purge that. You can't do that. And we'll look at one way that we accomplished that and the approach that we took. So as I was talking about a minute ago about the designing the bore field and running it up and everything. So we've all seen this before. It's pretty straightforward. You got to get your peak loads, get your building loads, get your 8760 energy model, and then that can be dumped into, hopefully, if you're using whatever bore field sizing program you're using. Typically, they will take that input from Trace or whatever energy modeling software you're using, hopefully. But you really have got to do that and be diligent in that effort so that it's a truest picture as you can, project at that time. So this is another thing that I see a lot of. Obviously you want reverse return because that's the simplest self-balancing system or solution there is. And you need to avoid balancing valves in vaults or bore fields. Okay, let's think about that, balancing valves. These are guys that are out there trying to balance these systems with balancing valves. Okay, great. What happens down the road or how are you going to coordinate that with your flushing and purging? You want that balancing valve wide open when you're flushing and purging so you get full flow. Well, maybe that happens, maybe that balance is done before the actual final flush and purge. We don't know. We take a little bit different stance on that. We would flush each loop individually, then we would have them pinch them off. And then once we interconnected them, we would hook the bore fields, each individual bore up to the laterals, then we would keep that at 100 PSI all through construction. I'm talking about new construction. And the funniest thing I ever had happen one day was we got they're near the end of the job and a guy out there with a backhoe hit the line. Well, it's charged with 100 PSI of air. And the thing started spewing. Well, the superintendent on the job called me and he was laughing. And I said, what's going on? He goes, because I thought something was wrong. He goes, just a minute. So he got himself together and he goes, there were 3 guys out there, a backhoe operator and 2 helpers. He said, they hit that line. They thought it was gas. He said the backhoe operator leaped off the backhoe. He said, and they started running. He said, we know where 2 of them are. One of them we think is still running. So, but that's just a measure because years ago we had another trade get into it and didn't say anything to each other. And so when we actually realized it, well then it wasn't in a convenient location to get to repair. So if you keep them charged and you can monitor it, and we ask them if we put pressure gauges on it and we will check it. My CA guys back in the day, they were visiting every site at least once a week. And we would go out, just to check on just everything, maybe announced or unannounced. I mean, and the way that we would design, did I miss something here? No. Okay, so these guys are using vaults here. So this is the way that we design. I told you I was going to design. This is a simple design for that client, i.e. in our industry or where we operated in school districts. They didn't have the main, so we dumbed it down, if you will. The KISS principle. It's very effective. So you will see what we've got. That single line, what we would do, we would put we would have a string of bores 12, 15, 16, like is shown here, with valves where we could isolate those 12 to 16 bores, okay? We'd have a valve box on the ground and give them a tool, and they could use a poly valve, and they could open and close it. So what we would have them do is just sequentially go around, turn off everything, purge the main laterals the best they can to start off with, and then go in and then do that same exercise, but just with 12 to 16 bores at a whack. And that really, after we started doing that, we didn't have the issues with air being entrapped or entrained and debris and everything. I know we had one job that we didn't do, but we got involved with, and you couldn't purge it. You couldn't have brought out a big enough pump to purge it because it was so huge. You would have, if you got up to the velocity you needed, you would have blown the thing apart somewhere, and you would have damaged definitely the heat pumps if you had those open. But so on the outside, so that's the way we would handle that. So here's another school that we did, and we did this whole design concept up to a 600,000 square foot school. We're talking 2,400 tons doing it this way, and it's very simple, it's very straightforward. If you have a breach somewhere, you're just isolated to a certain part of the building. Maybe they hit a bore field, and maybe it serves a classroom wing or something. So it's not where the whole thing's going to go down. But if you do get it, you can readily shut it off, and they can still operate because that's just 16 out of 50 or 60. So we would limit these things to 60 to 70 tons because that goes way back to when we first started the fusing tools back then. A regular contractor didn't have anything, they couldn't fuse anything greater than a 4-inch, so we stuck to 4-inch piping. Utility contractors had the bigger fusing machines, but mechanicals didn't. They had their fusing equipment only to a 4-inch, so we stuck with a 4-inch pipe. So that's how I got, that's what I came up with. So that's the mode we operate on. Again, it keeps it very simple. And then inside the building, here's your mechanical room. So in here, now it gets, you've got a lot of pipe running around, but structurally it doesn't impact the building. You're not hanging a 8 or a 10-inch pipe inside a building, because that impacts the structure. The other thing that we did is we ran the HDPE. We had no metal in our systems. And I know there's some pushback from maybe some code officials, and maybe certain areas don't allow that, but we were lucky enough that the areas we went into, sometimes I have to go in and talk to them and show them, and I had a packet that I would hand them about the HDPE piping, and I never got, they always accepted it, but we ran that and we used V-track hangers. I don't know if you're familiar with those, but you can use a V-track hanger. The pipe lays in it, so you don't get, the pipe doesn't loop on you or sag on you, and it keeps it plumb. So then, this is our mechanical room, and then the other thing that we use, this is in between a gym and an auditorium and a high school. One side of, you got, these are 20-ton units, and you've got 4 on each side serving these large spaces. If you notice, there's a pump on each one. And that's the other method that we use. We use demand pumping. The best energy management strategy is to have your energy use at the point of use. So this is the way that we operate. There was no central pump. Everything was done on demand pumping. And if it's flushed and purged, it's great. We don't put strainers on the systems either. Never have. These pumps become, if there's debris in there, the pumps will be sacrificial. And I know that goes, again, this is a simple down system to address a simple client. I'm not saying apply this to everything. Vaults are great if they're applied properly, and they're necessary in a lot of installations. If you're doing, a district system, which we've done several district systems, they're very that's the way you've got to roll. But in these simple systems, this is a better way to do it if you're doing, again, this goes back to knowing your client. And then here's just a single unit hanging up, and you can see, it's hard to see, but you can see a couple of pumps. So, there you get the push-pull pumps, depending on the size, because you've got low flow with relatively high head. These systems operate, and we charge them up to 35 PSI. And again, so we don't have any metal in the system, so we don't have any scaling, anything going on. I also have a situation in an apartment building, one of the cases that's still active, and they ran steel risers up through this 13-story apartment complex. That's good, no problem with that. But then they ran CPVC off of those to each unit. And so I don't know how many of you know, but the POE oil for your compressors in your units is not compatible with CPVC. It embrittles it, and it'll eventually fail on you. So we've got a whole building full, an apartment building, 13-story apartment building. And so far they haven't had any issues, and they have had, I guess they've had one failure. But I will go back and say I was doing some planning for a condo complex in Austin on Lake Travis, and it had, I don't know how many condos, probably a couple hundred condos, and it had CPVC, but it had been there since 1987. So the original units, when it was designed, the original oil, back when we had R22, it wasn't POE oil. It's only when we went to we started in the 410. I did check the new refrigerants, the 32 and the 454, or is it R1, what is it, R30? Anyway. Yeah, all the new refrigerants, proposed new refrigerants, or the new refrigerants, use that same POE oil. Now, there's a PVE oil that's used in Europe on some installation or some equipment, which doesn't affect it, but CPVC and POE oil do not marry up. And the other thing is know your contractor. So one of the things that we did, we developed a team approach with our contractors. And we listed in our specifications approved contractors. And we didn't exclude anyone, but they had to submit qualifications. So we would list 4 or 5 contractors, and then drillers as well. We had a good pool of drillers, and we would list those guys in our specs, and we would hold it tight to that. Now, you'd always get the guy that would, the driller or the contractor that didn't really know GEO possibly or whatever, they would come in with a lowball price, and then we had to fight with the owner to say, we've got three numbers right here within 5% of each other, and then we've got these guys that are 20% low. I said, there's a problem here, so you just have to kind of walk your client through that. But it's important that they've had some ICSPA training or some type of training. ICSPA has great training, and for design engineers as well. They need to go through that as well. But it really will make your jobs go a lot smoother if you're able to do that. If you have the luxury of having multiple contractors in each discipline that you're looking at. And as I mentioned earlier, the construction administration is paramount, because if you don't stay on top of them and monitor this, it's not say show up unannounced. So many of these cases, or almost all these cases, the MEP guy or MEP firm is just on call. It's when somebody calls me, and then we bill them by the hour. We've established an hourly rate or a daily rate or whatever works best for that project when you're going to come out and do your construction administration. So you've got a multi-million-dollar building, and you've got two field reports on the job, and I'm going, this is crazy. And you just turn the contractor loose. You don't know what's happened. So it's important that the CA, you stick with your clients and say, we have to do CA. We have to do the commissioning. We have to do the TAB. We have to do all that. If you want this to be successful, we have to do that. And then on your drilling, you know, the drillers, you get to know your drillers and you trust them. Now, you know, go check their work. We would not let them, you know, we're running all these 4-inch lines into the building, so we would not let them bury that until we laid eyes on it. And we would get in the field and we would check rollback. We only allowed butt fusion. That's a whole nother story. But so we would check rollback and make sure they had proper alignment and the rollback was there, that we felt, just visually, we felt that that was a good fusion joint. So you really need to consider that. And monitor the loop pressures. You know, that's what I was talking about earlier, put the air in the systems and monitor that. And, you know, 100 PSI, there'll be somebody will hear the hissing, so there'll be a tattletale there if, you know, like those guys that jumped and that one guy they never found again, I don't think. But that's something you really need to consider. Okay, the key takeaways today, you know, is about commissioning. And owner alignment is critical. Specification and contractor selection. Strong construction administration. And then retro commissioning for long-term performance. So you really need, I mean, these jobs have been incredibly, the schools, I can tell you, I mean, I have lots of data on schools, and real data, not something I calculated out, but we had one district that we did over 70 geothermal schools for in a period of 20 years. And they had used a prototype school, okay? So their previous system was a 4-pipe system. Air-cooled chillers, well, one of them was water-cooled, but air-cooled chillers and boilers. So we had multiple campuses. So we had 4 or 5 with chillers, and then we had the rest, a lot more with geothermal. You know, the elementary schools, this is in North Texas, in Georgia, Colorado, Phoenix. Elementary schools would show a 30% in energy savings. You know, middle school would show around 40%. High schools were 50% or greater. You know, and it all evolved to the more the use, the greater the energy savings. You know, high schools in Texas run 18 hours a day. And so you can see just, you know, we could project the schools, once they saw that, we never marketed it geothermal. We had that one guy that, you know, wanted to do it, and I did it, and he was the best advocate. So he'd go to their meetings of his peers and just rant and rave about GEO. So all of a sudden I just started getting calls from Dallas ISD, you know, all these Fort Worth ISD, all these districts going, wow. And then that equated out to Georgia somehow. I don't remember how that connection happened. And then it equated up to Colorado, up the Denver area. And then Phoenix, we did a pilot, actually, and proved it out for them. And Governor Brewer, when Janet Brewer was governor, she had her people call me, and we did a pilot out there. It was very successful. And one of the most interesting things I ever got involved with was Harvard. They were doing some, their green initiative, they were doing some geothermal systems, different types of systems, but the one they called me about was, had modular chillers, and the design engineer had designed the bore field, 500-foot bore, solid granite. You know, he designed the bore field with 55 bores. Well, Harvard Engineering had done their own calculations. They came up with a different number. So they get on the phone with me, and they said, we're going to send you all this. We got your name. We're going to send you all this, and we need you to tell us how many bores we need. So I said, oh, this is great. I got this design engineer who's been doing geothermal, and we've got the Harvard Engineering Department that's been doing their calculations. So I didn't, and they wouldn't tell me how many Harvard said, obviously. So I did my calculations, and I came out with 88 bores. And they go, well, that's good. We came out with 89. We'll go with your 88. And the design engineer had 55. So you can see that was a savvy enough client to realize that was not going to fly for them. But it's been a real interesting, experience over the years. Again, I wasn't a fan of it, but my first job out of college in 1981 was with a local gas utility in their research and development department. And in '82, I was looking at putting in, I had a test facility that I was over when they hired me. That's what they wanted me to do. I was running this test facility. And they wanted to put in a geothermal heat pump system. So I was in the throes of doing that. You know, I had a well driller lined up, and I was getting equipment, and then they cut the R&D department out. They went through an austerity program, and they whacked our R&D's always the first to go. But so I didn't get to complete it, but I was familiar with it, and there were some homes there in the Metroplex in the DFW that some pilots had built. They were underground homes, and they had geothermal systems on them. That's the first time I'd ever seen that. So so we stay with what's going on here. So here's Buck Elementary. I don't know if any of you guys have heard about this. This was a joint venture with American Water and Bosch. So I served as a technical consultant for Bosch for like 7 or 8 years. So we went in, and American Water, we wanted to demonstrate using the city water distribution system as your thermal resource. So we set this thing up, and they wouldn't let us put the water back into the pipe. So they had a diffusion well where we dumped the water. And since the water company, it was their project, they said, we'll just put it back in the same aquifer we're extracting it from, and that was good. So we did that. And you can see here that dashed line on the left over there is where ultimately we were going to turn it back in, but we had the diffusion well and then the option of the sanitary sewer. That didn't work out. So it was Jack Deanna was involved. He was kind of spearheaded that as well, or he was the one that spearheaded it. And then this is what we saw, because before they had a brand new 2-year-old boiler. And obviously, I don't know why we chose a green line for a boiler, but anyway, you would think it'd be the other way around. Anyway, the green line, is the boiler consumption, and the black line is the GEO system. So they didn't have any air conditioning. So now they have air conditioning. They can use the building year-round, and that became the most popular school in the district, right, Jack? Yeah. They used it for everything. Everybody wanted to have their graduations there. Everybody wanted to use it because they had air conditioning. So that was the results of that. So you can see right here in New York that this pilot that we did even demonstrated the geothermal, just what you guys can see here. And then we did our own modeling, and we added, we said, well, let's leave the boiler in place, and let's add just air-cooled, cooling. I think we considered split systems, and you can see that with the steam boiler and with the AC, they're operating at 87 kBTU a foot, and with the GEO, you're at 32. We did and when we consistently saw, the EUI, energy utilization rate, in the low 30s to the 20s, all the way down to 17. We did a net zero school called Lady Bird Johnson. It's located in Irving, Texas, which is right by DFW Airport. We had wind turbine. The district was using it as a demonstration project. We put wind turbines on it. They said they want to put wind turbines, and they said, how many should we put? And I said, I wouldn't put any on it. So we put 12. And they did The solar, the power company said you're not going to be able to put enough solar on the roof to offset the usage and demand in this building, and it took 2/3 of the roof because of the geothermal. You know, we were able to, it's a 2-story classroom part and the rest was all single story, but even with that 2-story part, we were able to achieve, that one was operating with an EUI of 17. We estimated it at 21. It actually came in at 17, and it ran that way. And last time I checked on it, they said, but we had an agreement with, and we had the principal sign it, the superintendent sign it, that this is how you're going to operate the building. For us to prove out, zero energy, or net zero, that you're going to have to operate. This is how it's going to have to be operated. Just tell us how you're going to operate it, and this is how it's going to be done. Well, we did that. Of course, they didn't do it, but we still achieved it. And then as they just opened it up, because now it's our most efficient school, it's still operating with it 95%. So it's been very successful. So just some questions so we can comply with the requirements here. What do you think the answer to number 1 is? Got any? Why is HVAC commission often ineffective when project completion and occupancy occur simultaneously? I chose C. Installation's not complete. Controls aren't set up. And what is the primary risk of declaring substantial completion before commissioning is complete? Yeah. And then post-occupancy commissioning within the first year is most justified when? I mean, this could be one or two. I chose B. And then retro commissioning is best described as C. And then again, all these, you just look at those. I think the answer to most of them is C, because in college I always knew when you're doing a multiple guess, I call them multiple guess exam, it's either B or C, right? You just had to pick one. So I just picked C, so. That's funny about my college career. I started in accounting, went through 3.5 years in accounting, and switched to engineering. The only thing I remember from accounting is how to cook the books. I'm good at that. I know how to cook the books. So I told you it's C. Oh, there's a B. See, so you made a 90 or whatever if you chose all C's. We don't see it. I don't, in my systems, I think I've only put glycol in one system, and that's the one here at this Buck Elementary. That's out on Long Island, Valley Stream, number 24. Does that mean anything to anyone?
The school was built in 1957.
Yeah. Yeah. But I'm out there. Here's my contact. My email's real easy. It's donpenn@donpenn.com. That's the original company name that I had. It was a sole proprietorship. I kept that. We formed another company called IEG in Texas. It was for the Texas operation. I think I had it registered in Arizona as well. The reason I had all the licenses was, in my prior days, I worked for Zales Jewelers, and I was their in-house MEP engineer, and I had a staff of like 4 designers, and we did all their stores all over the U.S. Back then, they had 3,600 stores. So when I rolled into business, I came out of the consulting world, and I had been the engineer for that school district that drove me into doing geothermal. I was their project engineer for the firm. When I left, I went to another engineering firm for 9 months, I had 100 engineers under me, and all I did was damage control, and it's driving me crazy. And then I have what I always refer to as the adult daycare, that you have to deal with the personalities. And so I thought, yeah, I'm not doing this. I'm going to go on my own. I'm never going to have an employee. And, you know, at the end of the day, I had got up to 40. We got up to 48 at one time. We were at 45 when I sold it. But it's just been it's been a lot of fun. So this litigation, I mean, what I'm trying to do here is to protect the technology. I'm trying to get, when I go into these things, and the design engineer, whether if he's a good guy, I mean, we can sort through it, and he knows GEO. I mean, we can get through it. But unfortunately, I don't get those guys. I get the guys that have never done GEO. So this is their, they're trying to apply condenser water theory and their design process to geothermal, and to a point it's very similar, but it's not. It's a different animal. I mean, you all know that. So my role now is what I'm doing is in the litigation world is I'm trying to support the engineer, and sometimes I've gone against the engineer, but I've actually with the idea of protecting him, because they're going to bring in an expert to the case. If the engineer already has an expert and I don't know who that is, and I know he's not a GEO guy, well then I will take the other side and try to protect the engineer the best I can. I mean, I'm very honest, I'm very open, and that's what the attorneys tell me. They say they really like me because you just tell us the truth, and that's all we want to hear. So I want to be in the position where I can tell the truth, whichever side of the case I'm on, whether on a GEO job, so that it gets dealt with right, and the community, if you could sacrifice it, I don't know whether you can or not in a lot of cases, but try to at least sacrifice the brand of geothermal. So I hope I was some help to some of you guys, and I really appreciate you showing up, and I haven't been up here. God, last time I was here was at ICSPA conference in Albany. I got a CGD there. They voted on me. I didn't have to take the test. I didn't have to do anything. They voted on me and gave it to me. So the whole board. I caught them in a bar, and I said, "Okay, where's my CGD?" Because I designed more GEO projects than anybody in ICSPA at that time, I'm sure.
So I think that deserves a round of applause. Thank you, Don. My guess is this industry is better off because you decided to get out of accounting. Hey, we're kind of at time, but let's throw a couple questions at this guy. He's got a unique background. Any hands raised? Or are you really anxious to get out to the happy? Oh, hang on. Here we go. Name and organization.
Yeah, Rick Clemenzi, Geothermal Design Center. I mean, would you advise anyone to put a balancing valve in a loop field? Why not just reverse return it and be done with it?
Yeah, you don't need balancing valves.
That was bad design, he said.
Hey, go figure.
Yeah.
I have no answer, Rick.
You're not trained in the business, gotta.
Exactly.
Gina DeRezzi from Ground Heat. Don, your accounting probably came of your value because it was something like cooking the books was reverse engineering, is it?
Yes. Yep.
Any other questions?
Yeah, Gino was actually pretty sweet. I ended when they always value off EBITDA, and I got in at 8.5. So I felt good. He's usually the average was 5. So.
Hi, Quinn Bedore, Vector Magnetics. Quick question about those as-builts. I know you said you wanted to go in and you wanted to have your surface locations. How rigorous do you recommend requirements for the as-builts where those bores actually end up?
I mean, we were having a surveyor, with the surveyor, it's evolved, but with the surveying technology now, we had them locate the top of each bore. Prior to that, we were using a tune locating device, and we would put those on the 4 corners of the bore field, and then every 50 feet down, the laterals into the building. And then like the valves, where we had the shut-off valves on each row of 12 to 16, we would locate those too. And then they'd have a wand, so they could go out there. They would have a rough as-built at that point. Say not like a surveyor, but the contractor would actually generate an as-built, and then they could use that to locate them. And then as the surveying technology evolved, we went to just point by point, because I think that's all digital now. I mean, that's all really slick.
Okay, folks, well, you can catch, did you have a question? Oh, yeah. One more, and then you can ask Don a question over happy hour.
Hi, I'm Megan Lim. I'm with the Grade Group. I've heard a lot about you through Rick and just other people, so I'm a big fan. And so I know you mentioned about the credentials needed, and like I know like I've also seen that firsthand too, how sometimes people can hire, like there just is a lot of confusion about, I think on both the consultant side and also sometimes on the building owner side about what credentials are needed. What, do you know what is going on in terms of like associations or just institutions trying to ensure that people know about these credentials and just are aware of it? And then like what would you recommend needs to be done in order for people to like, I guess like spread this information?
Yeah, I mean, all you can do is just keep pushing it. Just keep pushing the requirement for the credentials. I know, isn't it a requirement in New York, your CGD?
A lot of utilities now requiring HPA certification.
Yeah.
Sorry.
Yeah.
Jack Deanna, a lot of the new, the utilities that are getting into it are requiring HPA certifications only to protect themselves. And I preach that all the time, as a lot of us do. Because what we're seeing now with this becoming popular after 40 years is that we've gotten people going out and buying a magnetic sign that says they're geothermal experts, and they're putting out jobs that are horrible. But so what I've been talking to the people that I consult to is put it in your RFP or RFI that you have to have certifications. For CGD, typically you would have 3 years experience before you got to CGD, and I think, you remember how many jobs?
3, I think.
Three over 100 tons, right? Yeah.
Yeah,
So-
that was before. It's changed now.
Yeah, it's changed now, but that's the way we typically do it.
Yeah. Yeah, Jack and Garen and myself and a couple other guys were on the CGD board as well as the CGI board, where after you passed the test and you submitted your application with your work experience, we all reviewed and then weighed in on,
Okay, so as they say in Texas, we're fixing to go to happy hour. We're fixing to.
Fixing to,
Yep.
yes.
So sign in for your PDH credits over here, and then we'll see you at the happy hour.